Hi, I'm Dr. Sri Banerjee, and um, in this segment, what I'll go over is a little bit about Google Collaboratory. It's a really versatile tool which allows you to not only provide a kind of code which you can share between collaborators, but also the ability to annotate this code. And this is really important because you can then communicate which parts of the code make sense and which parts needs improvement. So let's get started. When you first open up the website, this is the first screen that you see, and you can either select one of these. I have created this file already, which I'll be sharing with you in the second part of this, but for now, you can just either create new notebook or cancel. I'll hit cancel so that you can take a look at these some of these features and getting started. So there's a lot of table of contents, machine learning. You can do data science. So depending on what you want to do, there's a lot of good sort of tutorials which you can follow. So you can choose to go through these sample visualization, or you can go into File, and when you're ready, you can select a new notebook. So I'm going to go ahead and do that. So once you select a new notebook, then you're ready to run your first code and then provide explanations for that. So this is how you transition from the beginning into then writing your first program. Now I'm going to go over a program that I've written to be able to take nationally representative data and then provide some meaningful conclusions from it. Thank you for listening. Hello, I'm Dr. Sri Banerjee, epidemiologist, biostatistician, core faculty. And in this video, I'll go over a Jupyter worksheet that I have created for the sake of running some simulation data and then proceeding to run some NHANES data. So let's get started here. So the neat thing about Jupyter Notebooks is that you can both provide scripts which are in text and scripts that are in code. So if you want to simply add additional code, then all you have to do is insert code. And what that does is it provides you the opportunity to write some code, and then when you run it, it only runs that portion of it. So let me show you what I mean by that. So in this code that I have written, I'm going to show you in a second here. So what I want you to pay attention to is there's a top panel, and then there's code. I'm sorry. There's a top panel where there is code, and then if you hit the run button here, then it will only run the code that is in that segment. It won't go beyond that. So let me do that just to see what happens. And so there's a list of different install packages, and what you do is you provide this command and install, and then these are the various packages which are loaded onto the Python by the Python program. So let's run this first set of code, and this is code that I've put together, and it's downloading some of the software that wasn't previously available, including the NHANES. So it's good to kind of see what took place. And so this is kind of, I see this as being the area where a lot of the packages that will be used within the program is being loaded. And then in the next segment, what you do is you run this out. And right now, at the beginning, you're running some simulation data off of linear regression. And you can kind of change around some of these parameters and see how that changes the simulated outcomes. But here's some residual plots. Here's the ordered values, theoretical quantiles, a QQ plot over here. So these are some interesting examples. I mean, first of all, take a look at the stunning color palette here. I mean, there's a lot of different colors being used to designate different areas, but you can take a look and see what all of this represents and means. So once you've run some of these plots, now we're ready to actually load the NHANES portion by making some adjustments in the names. As you know, variable names can a lot of times be confusing and not be very descriptive. And so if we're trying to provide some sort of description within a model, then you want to be able to use names that are descriptive. So let's run this. Let's first import the logit function from the stats model, and then load a model. So you can see with the green check mark that it has been run. So we're ready to proceed and take a look at our first logistic model, which is predicting diabetes. And there you have it. You've run your first logistic regression model on real data from the National Health and Nutrition Examination Survey. And this is your first beta coefficient, so the odds ratio. So with BMI, as you can see, here's some of the coefficients, and this is the relationship between BMI and diabetes. So how well is it predicting? Well, you can create a confusion matrix, and this is, you can run this. And all of this, by the way, all of this code is going to be available for you to run on your own and take a look at. I'm going to make the link available. So in the final, you want to provide an ROC estimate, an area under the curve. And so let's take a look at what that yields. So about 79%, which is pretty high, pretty good. As it turns out, BMI and age are good predictors of diabetes. And so there you have it. You've run your first model and also provided the predictive strength of your model and have generated some graphs which are pretty useful. So if you want to go through these steps on your own, I encourage you to look at this video slowly and take a look at the features and try to play around with some of these snippets as well. There are these code snippets available here, and if you want to add some of these features to a program that you're writing in Python, then you can use some of these snippet codes. In SAS, I use snippet codes a lot, and I can see the potential in using this as well. when you're trying to think of something that you have to quickly input. Also on the right hand side, there's some additional examples of snippets. So you can explore that. So that is, in summary, a Jupyter notebook with multiple features. So when you get a chance, go through this. Thank you for listening.